Hi, hello guys. My name is Girish Kumar GV, studying in SVC College in Vidyanagara, Bangalore, Department of Information Science and Engineering. My topic is corrosion. Definition of corrosion. Corrosion can be defined as the destruction or a deterioration or a loss of metals or alloys by the surrounding environment through a chemical or electrochemical reactions. Example: rusting of iron, a reddish brown scale formation of iron objects. Fe2 plus plus OH give rise to FeOH twice. For FeOH twice plus O2 plus 2H2O give rise to Fe2O3 into 3H2O. Hydrated ferric oxide. Mechanism of rusting of iron. Fe give rise to O plus Ze oxidation. Electrochemical theory of corrosion. According to electrochemical theory, when a metal such as iron is exposed to a corrosive environment, following changes occur. A large number of thin galvanic cells with anodic and cathodic regions are formed. At anodic region, oxidation reaction takes place. The metals gets converted into ions, liberating electrons. Metal undergoes corrosion at the anodic region. At the cathodic region, reaction take place since the metals cannot be reduced further. Metals atoms at the cathodic region are unaffected by the cathodic reaction. At anode oxidation takes place in the which the metals atoms are converted into their ions, liberating electrons. Fe gives to Fe2 plus 2 electrons. At cathode, the cathodic reaction is based on the nature of environment in the base absence of oxygen. Acidic medium liberation of hydrogen takes place. 2 H plus 2 electrons give rise to H2. The neutral or alkaline medium hydroxide ions are formed with stimulants liberation of hydrogen. 2H2O plus 2 electrons give rise to 2OH plus H2. Presence of oxygen in acidic medium, absorption of oxygen takes place. 4H plus O2 plus 4 electrons give rise to 2H2O. Neutral or alkaline medium hydroxide ions are formed. 2H2O plus O2 plus 4 electrons give rise to 4OH. Then iron ions Fe2 plus form anode combined with hydroxide ions are formed cathode in iron hydroxide on the surface between the anode and cathode areas. Fe2 plus 2OH gives rise to FeOH twice. Iron hydroxide further reacts with oxygen, the water, forming hydrated iron oxide, which is the corrosion product. 4FeOH twice plus O2 plus 2H2O gives rise to 2FeO3 into 3H2O. Types of corrosion: differential metal corrosion, differential aeration corrosion. Differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are connected with each another and exposed to a corrosive conducting medium. The metal with lower electrode potential acts anode, undergoes oxidation, gets corroded, and other metal with higher electrode potential acts as a cathode. Undergo reduction and protected from corrosion. This type of corrosion is known as the galvanic corrosion or differential metal corrosion. The rate of corrosion depends mainly on the Difference in potential between two metals. Higher the difference, faster is the rate of collision. The reactions may be represented as at anode m q raised to m plus plus electrons at cathode. Reaction take place depending upon the nature of the element. 2 plus 2 electrons q raised to s2 or 2 s2o plus o2 plus 4 electrons q raised to 4oh. Differential aeration corrosion. When metal is exposed to a different constructions of air or oxygen, part of the metal exposed to a lower concentration of oxygen becomes anodic and undergoes corrosion, whereas other part of the metal exposed to a higher concentration of oxygen becomes cathodic and remains unaffected. This kind of a corrosion is called differential aeration corrosion. Example: iron rod partially immersed in a NaCl solution. Part of the metal immersed in solution is exposed to a lower concentration of oxygen becomes anodic and undergoes corrosion, where part of the metal outside NaCl solution is exposed to a more oxygen becomes cathodic and remains unaffected. The anodic and cathodic reactions are at anode Fe gives to Fe2 plus 2 electrons. At cathode 2s2o plus O2 plus 4 electrons gives to 4OH. Fe2 plus OH 2OH gives to FeOH twice in diagram. Thank you guys.